Hi guys, today I would like to introduce new concept units and measurements. Units. So these are very important in physics. Without unit mentioning whatever we say that gives meaningless information. Suppose I am asking a question that is what is the weight of this player? Weight. So when it comes to weight, so we have to mention that weight in terms of numbers. Suppose if I can take that as a 75. So it's a number. And this 75 is a incomplete information right at here. So we need to add something. So that something is, suppose if you can take that in terms of kg. Now whatever we are mentioning to represent that number in terms of certain quantities, so then only it's having its meaning. Now I can say the weight of this player equal to, now it's a 75 kg, so that is a meaningless statement at here. Now otherwise, if you can take certain another question, suppose if I ask you, you want to measure certain length. So take this instrument and try to measure certain length. Now this is the a measuring instrument. We already know that it's a measuring instrument. It measures something. Suppose if I draw a certain line with the help of this. Suppose if I draw a line at here. Suppose if you can take a draw on a line at here. Now I want to measure what is the length of that line. So the length of that line we can measure by using this instrument. So this instrument, if we can keep something close to that, we can measure that in terms of certain centimeters, or we can get certain quantity. Suppose let it be this as a, for a time being, 10. If we written this as a 10, so again this gives us an incorrect or the incomplete information. We need to add something at here. So that's something the preferable which I can take at here, 10 centimeter. So this centimeter at here to me is what we call as unit. So the physical quantities means nothing but which we can measure. So what are the things we can measure? We can measure length, we can measure mass, and we can measure time. So these three physical quantities which we know that, and these three physical quantities which we often used to measure, and length, mass, time. Apart of that, certain another quantities. If you can take for your known language, from this we can measure velocity, and we can measure speed, and like that we can measure so many accelerations, like that. So these all are physical quantities. So velocity is a physical quantity, speed is a physical quantity, acceleration is a physical quantity. And according to your the basic knowledge, these all are coming with units. Okay, so here I can give that how we can classify units. So we used to follow the units of SI unit, System of International. So it's a bureau or it's an agency. So it gives certain guidelines to all over the countries to follow the units to common or. So we are following SI unit system. And before that we already know, so in the elementary knowledge you know the CGS system of units, and the MKS system of units also we know, and the FKS, foot, kilometer and second. So this is the British system of unit. So this MKS meters and kilogram and second, and CGS centimeter, grams and second, and SI units it gives as a common system of international. It's one of the bureau. So we used to follow all over the physics in the standard SI unit system. So according to SI unit system, so the physical quantities are derived two categories. One is the basic quantities. Very basic means these quantities will be come with a definition. So there are the 7 basic physical quantities are there. So if you can see that as a table right here, so these are the 7 basic units. Now among the 7, the first one we can take as a length. So this length is a basic. I will define what is the length. And a part of the next one is the time. There is these are having standard definitions. Suppose if anybody asks define time, being a science students we should have the knowledge to define what is time. Or you define a length. If asked that question seems like crazy. Oh, what is length? Yeah, till now we do not ask this question right ourselves. Length means what? So there is a certain definition is there. We will go through that definition. And length, mass and time. So these 3 you already know that. And a part of certain substance you already know it. So these 7 are. The fourth one electric current. And the next one is temperature. And next one is a amount of substance. And last one is a luminous intensity. I hope you know what is the length. Length we will measure in terms of meter. So we can use an abbreviation unit small m, lowercase m, and time for second. So that is also lowercase s. Mass, it's a kilogram, kg, and electric current unit goes to ampere, it's capital A, and temperature units are kelvins. So don't be confused that temperature we used to measure in terms of degree centigrade. So this one please be careful. So the basic unit of temperature is a Kelvin unit. And amount of substance, mole. So this is the very necessary unit we need to deal in the chemistry. It's a very necessary unit. Amount of substance. So its unit also goes to mole. And luminous intensity, it's a candela. What is the meaning of luminous intensity? So this here I need to explain, since I think we need to know about intensity. Who is having intensity? One cross question. Who is having intensity? Bright objects. Bright objects. Or at a particularly here I can take stars. They are self-luminous objects. The objects which can give light, those are calling as self-luminous objects. It means to measure the intensity of light. So that is also one of the fundamental unit. What was that? To measure the intensity of light, how much amount of light is coming. So that is we will measure in terms of unit candela. We used to represent with the abbreviation units CD, suffix CD. So these 7 we define as basic units. Why it is called basic units? So here I can say units are classified into 2 categories. One is the basic, second one is derived. So I can explain it here. So the 7 basic units, my dear students, so please try to remember these all. It's not a big deal to remember: length, mass, time, electric current or temperature, amount of substance, and luminous intensity. It's very easy. And the corresponding units. So here I can stress you that you should please learn at least the 3 definitions of the length and time and the mass. So the corresponding definition is already given in the NCERT tabular form. So we will learn that for a moment. Just to give a moment, I can explain that one. So these 3 definitions we need it. They are not very big. So but as a standard definitions. Now we were discussing about units. So these units are categorized 2 categories. One is the basic units, another category is derived units. Let us explain about what is derived units. So here I have taken derived units. What is derived? Derived. So derived means it has to derive with the help of the basic unit. Okay, let me give an example that gives us a very standard understanding, better understanding. Suppose I want to write the velocity unit. What we can write the velocity formula? Displacement upon time. So the displacement is in terms of meters. We will measure displacement in terms of meters, and the time we will measure in terms of second. Now the velocity unit, what we can write? The unit of velocity, meter per second. Now here this meter per second is the unit of velocity, and this is not basic unit. This unit we derived at here. So this we call as derived unit. So if we can take that, we will derive so many units. So other than the basic, so we will encounter so many derived units, and in the course of time you learned also, and in the coming classes you will learn much more. All are the derived units, means with the help of the basic units what we are going to derive. So here let me toss one more: acceleration. I hope you remember the acceleration formula. Acceleration means nothing but the velocity upon time. So acceleration units becomes as a velocity units, meter per second by against second. So acceleration is equal to meter per second square. Now here the acceleration is also a derived unit. Yeah, like that. By using basic units, so how we are going to derive? So those all are called derived units. Let us come to the definitions of the length, mass and time. For the length, so how we can measure 1 meter? Let's see the definition of length. So how we can define length? So the length here we define as so the distance traveled by light in vacuum in 1 second. That is defined as 1 meter. So let me explain that clearly. Suppose if we having vacuum, so just imagine this space is entire space is a vacuum. Now we know the velocity of light formula. So the velocity of light c equal to, so it approximately 2.99 times 10 power 8 meter per second, or roughly we take that c is equal to 3 times 10 power 8 meter per second. So this is the speed of light. Now what is the speed formula? Speed equal to distance upon time. Now you know the speed at here, the speed of light. So if we can write the units, it's the meter per second. Now to define 1 meter, To define 1 meter, the distance traveled by light in 1 second. So to define 1 meter, so the distance traveled by light in 1 second. Now if you can take 1 second, the speed of light roughly approximately I can take 3 into 10 power 8 meter per second. So this is also meter per second. The time is also in terms of second. Sorry. If you can take that in terms of second. Now if you can do this calculation, that is also in vacuum. That's also in vacuum. So that we define as 1 meter. So that's the definition we are getting. The meter is the length of the path traveled by light in vacuum during a time interval of 1 over 299. So if you can see, this is the big number. So this is the value, the speed of light. If you can write that in terms of that, 2.9 into 10 power 8 meter per second. So that gives us a definition of length. Crazy definition, but try to get it meaning. Now let's see the second definition, mass. Mass units are the kilogram. Now we know that mass is having a standard unit. Suppose if we go to market, so they used to keep 1 kg of standard stone, that equivalent to how much quantity we are taking. Suppose if you want to take 1 kilo tomatoes, so they keep 1 kg standard, 1 stone they can keep it. What is that stone? So that is the stone. We can take it from at here. Suppose that is a very basic standard unit. We are taking that. 1 second. So this is the what is really standard. It's not a stone, it's a metal. So this metal is exactly, it's an alloy. Alloy is a combination of metals. So it's a combination of the platinum plus iridium. It's having certain dimensions. If you can see, it's having the dimensions of, so here is given that 3.9 centimeter height and the 3.9 centimeter of diameter. So this is the standard size of a metal which they kept at international units of the bureau. So here you can see the SI standard unit of mass is a cylinder of platinum iridium that is kept at International Bureau of Weights and Measures, that is nearby Paris. Now that metal of that dimensions we are taking as 1 kg. Yeah, obviously the same metal we cannot get everywhere, but that replicas means that duplicate can be done. So our Indian Weights and Measurements organization, so that will be take this replica or duplicate, so they will give one of the standard unit, so that we will take as 1 kg. So if you see the exact definition of mass 1 kg, the mass is defined as the kilogram is equal to the mass of the international prototype. Prototype means which exactly the same prototype of the kilogram. It is a platinum iridium alloy kept at International Bureau of Weights and Measures. So this is the standard 1 kg unit. Still now we are following. So from the 1889 onwards. So that gives the standard definition of mass of 1 kg. It's something like crazy. So now the next unit we can define as time. So if you can take that time, the third you can take time. So how we can define time? Its definition is something entirely different. So I hope I can make you understand. Suppose if you can see the definition of time. So 1 second is duration of these many periods. A big number is there. I can encourage, no need to remember that. These many periods of the radiation corresponding to transition between two hyperfine levels of ground state cesium 133 atoms. Oh, it's something like, so what is exactly it means? To make you understand in a simple language, suppose if I take cesium 133 atom. So the cesium 133 is one of the atom. Cesium is in the periodic table, it is there. So that is the one of the atom, you can take it. Now it is having two levels. Suppose if you can take level 1 and level 2, just like hydrogen atom, you can just imagine. Hydrogen also having the atoms. So if you can take this as in a first orbit, this is a second orbit. Now according to definition, I need to take this number 9192631770. 9192637710. Yeah. Now suppose if you take an electron in this hydrogen atom, in this atom cesium Ce133. So if this electron is jumping back and forth from the first orbit to higher orbit, from the higher orbit to first orbit, in how many times? So it is jumping back and forth in these many times, 9192637710, these many times. It's something like a phone number. If an electron making transition between the levels of the cesium 133 atom when it is in the ground state, how many times? So these many times. So how much time it takes to jump back and forth in the hydrogen level atoms? How much time it takes? So that we define as 1 second. So the 1 second is defined as the electron transition between in the cesium 133 atom between the hyperfine levels. How many times? So 9192637710, these many times. So how much time it takes to jump back and forth those many times? So that is defined as 1 second. So its definition is little more crazy. So likely if you can go through the rest of the definitions for time being, so these all we do not need it, but to make you understand I can explain the rest of that. So the next one goes to electric current or ampere. So ampere is nothing but its unit of electric current. So it can define as, suppose you take two parallel wires. Better I can do that in the white space so the visibility is more. So to define ampere, so from earlier knowledge, suppose if I am having two conductors, means in the two current is flowing, so they are kept at 1 meter apart. So the distance between them goes to 1 meter. So their diameter is almost all negligible, infinitely small, the diameter. Almost all you neglect that. And this setup is kept in the vacuum. So this total setup is kept in the vacuum. So if these two setup is kept in the vacuum, what happens when the current is passes through them? So because of the certain magnetic field, so these two conductors will repel each other. So that's the earlier knowledge what we already have it. Now when they are repelling each other, so they should apply a force of 2 into 10 power 7 meters. So meters, Newton meter. So 2 into 10 power 7 Newton meter. So if this is the amount of the force is they are applying on one each. To apply this much amount of the force on one each, how much current should passes through them? If you can pass through conductor certain amount of current, so they can apply force each on each. So if they can apply a force of this much amount, 2 into 10 power minus 7 Newton meter amount of force, then how much amount of current is needed? So that current we define as 1 ampere. So that is according to standard definition because it's a very basic definition. So like that we can define the rest of the thermodynamic temperature also. Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature at triple point of water. So this concept we do not know, my dears, at triple point. So when the time comes triple point of water, I can explain this definition there. And mole, yeah, mole definition we already learning from the class 9th onwards. So the mole is nothing but an amount of substance. If you take carbon 12 atom, so C12. So in the C12, how much we can take? We can take as in 0.012 kg of carbon contains how many number of carbon atoms? So that number we define as a mole. So this definition we already knew that. And apart of that, the last one goes to Candela or the luminous intensity. So it is defined as the candela is defined as the luminous intensity in a given direction of a source that emits a monochromatic radiation of frequency. So these words are not known for us, but I can give a guarantee that when the right situation comes, I would like to explain that in that time. Otherwise, if I explain right now, so it will be go above your heads. So that makes you not giving interest towards the subject. So I don't want that to lose your interest towards the subject. But when the right situation comes, so I would like to explain these concepts at there. So these 7 are we defined as 7 basic units. So apart of at the 7 basic unit, I would like to remind you 2 more which we can call, should not call basic units, but we can use that as in another manner. One is this solid angle. One is the solid angle, one is the plane angle. So this is the solid angle and the above is known as plane angle, an angle. So this we already know that angle. Suppose how you define an angle. Suppose if I take a circle, if I draw a circle, so this is the circle. Let me take this having a radius r. So this is the radius r. Suppose I am at here A and I went after certain time at B. So now the B is also at a distance of r. Now this distance you can take an r. Now we define as angle means nothing but this is the angle. theta. Suppose if I shaded this region, so that is the angle covered by the A to B. Now, if you take the points from the A to B from here to here, so this side we call it as length, because A to B is certain length. Precisely, we can call that as an arc length. Okay. Now here we can see the formula to define as an theta. So to define as in a theta, so we can use a formula right now at here. Suppose if we can neglect this small arc, means that angle you can neglect that. So it's something look like this. Something look like this. Now here I just neglected the curvature. So it is supposed to be like that. So we just neglect the curvature. Now here you can write it as in tan theta. So tan theta, what we can write it that. So in this case we can write the tan theta. But here we need to measure the theta and angle. You forget about this tan theta. Right now we don't want that. Just we can write the theta. So the angle theta formula here we can give arc length by radius. Arc length by radius. So to calculate the theta, how much change in the angle? We need to arc length. Here the arc length is nothing but AB by radius goes to R. So here I can take it as R. Now this we can see in the different way. Suppose if we can draw a circle at here, the same way, and if we can want to measure the angles, so from here to here you can measure the angle, and I would like to know the known angle. So here the angle I can take as a 90 degrees itself. Suppose if you can take that 90 degrees, and the angle here we know that by elementary knowledge it's the 90 degrees. 90 degrees means nothing but from the A to B. Now here we can say what is 90 degrees? 90 degrees means nothing but this much portion. So this is the 90 degrees portion. Okay. Now here we can define as a theta. So we can define theta at here. Theta, it means here equal to 90 degrees is equal to theta. 90 degrees is equal to, suppose if you take this radius as capital R. Here the arc length from here to here, the arc length becomes as an AB upon radius is capital R. So this is the standard definition for angle, or this angle only we already called as in another is a plane angle. So the angle theta also having a definition. So that definition we can get it from it here. So theta, d theta or small angle d theta. So the d theta equal to ds by r. So the ds means now this part. So this part only we call it as arc length. That is called as arc length. And the r means nothing but radius. Now the plane angle, so plane angle d theta equal to ds by r. So it's having units, plane angle units are the radians. So that is the basic unit of radians. I hope you got it. Now one more here we need to learn the right now below that. So this is the another type is called as solid angle. Solid angle, when it comes to, you need to think that just like a three-dimensional, just like the angle what we have taken, so that you take as a three-dimensionally. It means I need to draw as a three-dimensional angle. That is the one and only the difference, three-dimensional. Suppose here you can see in the place of ds, now here you can get as an area. We got it because we are this one we are assuming as in a three dimensions. Now here the angle made by the this part d omega equal to dA by r square. Now here the radius square. If you can see the definition, the solid angle d omega is the ratio of the intercepted area dA of a spherical surface. It's a spherical surface, to the radius square. So here the radius r is the radius of the sphere. So this ratio, intercepted area upon radius square, which gives an angle d omega. So this angle known as solid angle. So these two angles we used to measure when the situation comes. So this also we will learn as a part of basic units. So the 7 basic units you can take as length, mass, time, electric current ampere, Kelvin temperature, and next one mole, amount of substance, and last one goes to luminous intensity. Those are the 7 fundamental units. Apart of that, we need to learn in the SI units the 2 angles. One is called as plane angle d theta, another one is called as solid angle d omega. So when we apply problems to this d theta and d omega, we need to understand that much better.